Okay, so as I mentioned, Liam is not going to be able to join us today to do his talk about Octant, which was a monitoring tool. It's a tool used to monitor Kubernetes infrastructure on which Kubeflow rides on top. So hopefully he is feeling better down the road, and we'll be able to see his talk at a later time. So I thought we could use this opportunity to do a quick introduction to Kubeflow. And the reason for this is that we've had quite a few folks, at least some of the early feedback was that people were completely brand new to Kubeflow, and that some of the talks kind of started in the deep end and folks got lost pretty quick. So what we're trying to do in these meetups is at least have one lightning talk, if not two, that kind of just does a core sample of different ideas, theories, or practices inside of Kubeflow. So people can start kind of piecing together some of this information. So I think last meetup I did a short talk on architecture and components. So I thought on this one I would do a quick introduction to Kubeflow where I focused primarily on workflows, which is a little bit more about kind of the theory and the abstract around why Kubeflow. And then I thought it wouldn't hurt to actually jump into the central dashboard of Kubeflow and navigate through it. And as we navigate through it, point out some of the features of Kubeflow, but also how you can interact with different add-ons that you can put into Kubeflow. Because I suspect a lot of folks that are probably watching the playbacks or coming to the meetups may or may not have already installed Kubeflow. So they only see screenshots if they look at the docs, and they don't actually see the product live. So it may not hurt to kind of help people navigate through that and what they should expect to see, right, if they successfully install Kubeflow. All right, so let's kind of level set and first answer the question, why Kubeflow at all? The first question, I guess, to ask before we answer why Kubeflow is, what does machine learning and data science have to do with Kubernetes, right? And there's three kind of motivations as to why Kubernetes is actually the ideal infrastructure on which to run your machine learning workflows. The first one is going to be around this idea of portability, right? Where you want to be able to write once, reproduce, and run everywhere, right? And at a high level, this basically means, hey, I want to do work on my laptop, but this work on my laptop at some point has to scale in production to serve X number of people or do X, Y, and Z on GPUs in the cloud, et cetera, right? And if you've ever developed, whether it be applications or services or whatever, is that you know that laptops are radically different environments than production grade cloud deployments. And there's many things to consider along the way. So the more that our tooling can be written once, or the more that our code or our components can be written once and know that they can actually be reproduced and run in a different location, that saves a lot of headache for a lot of people, especially the folks that get handed the code and said, hey, you run this in production, right? So I'm sure everybody has heard, well, it ran on my laptop. I couldn't possibly know what the difference is between that and running on GCP or on some large scale AWS environment. So containers here are going to be a key ingredient here in being able to develop locally, right, using containers, but at the same time, know we can use that same infrastructure in the cloud. The other one is going to be microservices, right? So as I previously mentioned, Kubeflow is not a monolithic executable or binary. It is an amalgamation of different components that provide very specific functionality in a machine learning workflow. That's what kind of makes Kubeflow a machine learning platform, because it's got these different pieces of functionality that are all stitched together. Now, some of these you can swap in and out, some you can run standalone, some definitely don't exist in a universe outside of Kubeflow. So basically a services architecture, or microservices, right, is we're going to want to typically run those things on top of Kubernetes, right? When you think about decomposing an application or writing a microservices-based application or a services architecture, you normally immediately are going to think, well, we're going to run this on top of Kubernetes versus bare metal or VMs, right? So because Kubeflow is made up of a ton of different services and applications, Kubernetes is like a natural fit for that. And then the last one is going to be scaling, right? And here it's a bit interesting because scaling, often we think about, hey, how can we get as big as possible? Like, how can I get all the resources that I need as quickly as possible when I need them? And we obviously know that Kubernetes is a great piece of infrastructure to help us achieve that goal. But oftentimes in data science and machine learning, it's not just about how quickly we can scale up to get the resources that we need to run our pipeline or our workflow. Oftentimes it can be about how quickly can I scale it down. And this is important because in production, many machine learning workflows are going to require access to GPUs, right, to be functional, right, or to deliver the performance that we expect or the scale that we expect. And GPUs are super expensive. So it's rare that you're going to find even a large enterprise with big data science team and big budgets that is going to allow individual data scientists to have their own allotments of GPUs that are primarily reserved to them. Oftentimes, these are going to be shared resources, right, that are very expensive. So just as quickly as we need to get access to those resources, we need to scale down and release those resources so that other people can come in and use them. So Kubernetes, again, or a container-based architecture, is going to be essential in being able to facilitate that. So that's why when we think about machine learning and data science, what does that have to do with Kubernetes? These are three solid reasons why Kubernetes is an excellent infrastructure on which to build our machine learning and data science projects. However, there's a couple of things to consider here, which is that even though we can arguably say that it's still the early days of data science and machine learning, I think that if you know enough about the industry, you know that maybe a little bit less than half or way more than half of machine learning models never actually make it to production or deliver the business value that people are expecting from that. So it's pretty straightforward, at least from my estimation, as to why that happens. But primarily, it's going to be around skills. Look, it's still the early days. Recent grads, data science grads, are not going to be familiar with how real enterprise, IT works. Some of the software is not as mature as we would want it to be. There's also not a super well-defined MLOps methodology. Like, for example, if we want to do DevOps at our company, it's pretty easy to go hire an agile or a DevOps coach. There's tons of books that have been written around DevOps. MLOps is still an evolving discipline, so there's no hard and fast rules at the end of the day on how it should be done properly, because all enterprise environments are different. They have similarities, but they also have differences. So it's a question of what is the MLOps methodology? And this will get resolved over time, right? This is just a question of the space maturing. And then finally, collaboration, right? Now, as we'll see in one of the slides, that when we actually kind of implement an end-to-end machine learning workflow in an enterprise, there's going to be a lot of personalities, right, that are going to get involved in that process. And regardless if we're doing a machine learning project or building a web app or doing an API or a service, whenever multiple personalities within an IT organization have to get involved, everybody's got different tools, everybody's got different ways of working. That collaboration is very challenging. So in a weird way, these different things all collude to make it a bit challenging, right, to be able to bring machine learning models to market and have them deliver business value. But I'm confident that these things will be resolved over time. So one thing that can help us here, right, is going to be combining machine learning and Kubernetes into something that we know as Kubeflow. So the net is that Kubeflow is an open source project that is perfectly converged here, right? That everybody wants to do container-based architectures, everybody wants to do Kubernetes, and everybody wants to do data science and machine learning. And if your company has both of those initiatives, then at that point of convergence is Kubeflow, right? It's the physical manifestation of those two things coming together. In a nutshell, it's essentially a toolkit, right, for machine learning workflows that aims to handle end-to-end everything that you need to do to bring a model to production. That's going to include the data, the training, the tuning, the serving, as well as the monitoring. As the footnote, Kubeflow was launched back in 2017 by Google. It originally started inside of Google as a way for them to better manage their TensorFlow projects. So with that said, let's jump into a little bit of the theory around machine learning workflows and how they manifest themselves inside of Kubeflow, and then we'll actually jump into the Kubeflow UI, and we'll do a basic navigation and then highlight some of the core functionality, but then also how you can use add-ons to kind of simplify some of the steps that otherwise would require a bit of considerable work. All right, so what is a machine learning workflow? So net, a machine learning model is code, right, that gets smarter through training with data. So if we start there, we're going to need to have a workflow, right, that's going to facilitate this. And in this workflow, we want to do a few things, right? We need to gather our data, right? So what if we're building an email or a spam detection system, right? We're going to need access to emails, right? Or if we are building some sort of a super fast mortgage application approval workflow, then we're going to need access to maybe credit history, tax information, whatever it is that might go into a mortgage application. And then we're going to need to pre-process that data. So here, let's just say, use our spam example. Okay, how do we deal with special characters? How do we deal with colors and fonts and hyperlinks? Do we care, right? Maybe we have a data set that is from two different sources. One is from a database. One is from some sort of spreadsheet that's not normalized, right? Okay, so how do we pre-process that data so we have a single data set? What if we're missing data? What if we have partial data? Like, how do we need to scrub this data to make it usable by the system? And then obviously we want to find the best model, right? We define what our objective is. Okay, we may run 50 different experiments, and we want to find that one model that's going to give us as accurate an answer as possible. Then we're going to want to train the model, and then we're going to want to test it, and then we want to evaluate the results. And it's a bit of a virtuous cycle, right? Where new data comes in, new information comes in, perhaps there's a new algorithm we didn't think about, there's new tuning that we want to do, right? We just kind of keep iterating through this. And this can be simply because new information becomes relevant, or the life cycle of the model, the timeline elongates, so it's naturally going to need to iterate in order to continue to meet the objectives that we set out for it. So that being the case, if we kind of at a very high level try to visualize Kubeflow, there's a couple of just key areas, right? There's the tooling, there's the machine learning tooling, and oftentimes we can think about this as frameworks, right? So this is going to be TensorFlow and PyTorch and XGBoost, et cetera. Those are our frameworks, right, in which we do our data science or our machine learning. And then within Kubeflow, there's going to be a variety of different services and applications and scaffolding that we need to do various tasks within the workflow, right? So here we'll have our notebook servers, more on that in just a second. We have to manage the data, so we're going to have our volumes. There's going to be artifacts potentially that we need to work with, and maybe there's going to be metadata as well. We need some sort of a user interface in which to kind of navigate through all these pieces. We need to serve the models. We need to tune the hyperparameters, right? There's a bunch of different pieces that all have to come together. So this is going to be your applications and your scaffolding. And then there's also kind of external or add-on components that in and of themselves provide vital functionality to Kubeflow, but could potentially, are independent products all their own, right? So for example, SDO and Argo and Prometheus, yes, even MySQL and Postgres are used inside of Kubeflow. So these are all kind of open source projects or technology that's completely independent that's also being leveraged inside of Kubeflow. And if you've ever done a Kubeflow installation, whether it be from a package distribution or using the manifest, you will quickly realize that there are many software components that come into Kubeflow. So, right, to not mince words, Kubeflow is definitely a complicated piece of software that it oftentimes can be very hard to wrap your head around internally what's happening with all those pieces. That's why I always recommend starting with a package distribution before moving to kind of trying to install the thing manually using the manifest. And of course, all of this runs on top of Kubernetes, right? So Kubeflow is a machine learning toolkit that wasn't designed to run on anything but Kubernetes, right? There could be other technologies that you can kind of retrofit to do machine learning stuff, like say Apache Spark. But I think even Spark didn't support Kubernetes. I want to say not until the beginning of this year, even though it's been in development for a while. So cloud native, right, is something that is of the first order for Kubeflow. It runs on Kubernetes. Yeah, that's what it's designed to do. And when we have that as our infrastructure, it means we can essentially run it on Google Cloud, on AWS, on Azure. We can run it on-prem. We can run it locally on our laptops. And that's kind of the beauty of this containerization. So that's the high-level visual of kind of all the pieces. Obviously, if this can go into a straight rabbit hole just clicking on any of these cells, but I wanted to give folks a visual that are brand new to Kubeflow as to kind of what the main pieces are. And then another view that's useful is going to be when we talked about the different personalities or personas that get involved in a production grade enterprise workflow, right? And specifically, if we're using Kubeflow and the different pieces of functionality that it provides through the workflow, you can see that at the very beginning, it's primarily going to be the work of data scientists interacting with data engineers. So these can be database administrators. These can be people that do ETL. You may even have security people that get involved. Data scientists, A wants access to data. What? Right? Not going to happen unless we, clean up some of that data or obfuscate it in some way, right? So these are the folks that at the very beginning are going to be primarily working with the data acquisition, the data preprocessing, and then figuring out what the correct models are to achieve the objectives that we're looking for. And then as we move further to the right, we can see that we're ready to start operationalizing or moving these models into production. Data scientists are not always going to be Kubernetes experts, and Kubernetes experts are not always going to be data scientists. So that means that we're going to, at this junction, kind of figure out how to work together. And one of the ways to do that is to have a common tool set like Kubeflow so that you can get end-to-end visibility across the board. So when the MLOps engineers kind of take over, DevOps people potentially as well, we're ready to move that into a serving state, right? And then you may find that security also comes up in this part, maybe even legal, right? So we can easily, and we've seen this, right? Especially around the ethics around AI and the biases around, potential biases around some algorithm choices, right? So here, for example, let's say that we were tasked with building a model that could approve mortgages within 60 seconds with a high degree of accuracy that the person that we extended the offer to would not default on the loan, right? So let's say that we do that, and the business does super, super well. We've realized this is the secret sauce. If you can get your mortgage approved within 60 seconds, then you're 10 times more likely to be a customer. We start killing it in the industry. It's taking off. Everyone's trying to replicate what we're doing. And then we realize, then maybe a year later, we find ourselves in a class action lawsuit because some folks feel that they were being denied mortgages because of some characteristic or something that they filled out in their application. Now, how are we going to go back, let's just say 6 months, replicate that exact environment? So here I'm talking the data, the model, the metadata, the artifacts, like the entire environment, soup to nuts, so that we can then run similar profiles through it to try to understand, is there some sort of bias in the way that we've built this sort of thing? And if we can't recreate that environment, then it's a bit challenging for us to answer that question, or it would be a lot more painful to do that. So what I guess my point is that there can be personalities within the organization that are not listed here that can potentially get involved in a machine learning workflow. I guess maybe my point is that machine learning is not without peril. Maybe that's what I'm trying to get at. But anyway, the point is that how do we put Kubeflow into a machine learning workflow, right? And we basically want to break it up into two phases. There's going to be our experimental phase, right? There's going to be our production phase. In the experimental phase, again, we're just identifying what our problem is. Maybe it's a spam detection. Maybe it's, hey, we want to quickly approve mortgages. Maybe we want to build a chatbot that can translate from one language to another super quick, or whatever it is, right? Maybe natural language processing, or we want to do facial recognition, whatever it is, right? In step two, we're going to be doing what I already described, which is acquiring our data, pre-processing it, analyzing it. And then in step three, we want to choose our frameworks and our algorithms. Now, depending on the problem that you're trying to solve, one framework might be a better choice than another. Like if you're doing computer vision, or if you're doing NLP, or if you're doing something more generic, maybe PyTorch, maybe TensorFlow, right? There's a variety of different frameworks that you can go with. Fortunately, for the most part, Kubeflow and its components are agnostic to frameworks for the most part. Now, depending on what problem you're trying to solve, there's going to be different algorithms, right, that are going to come into play. Some are relevant to your problem, some are irrelevant to your problem, right? So oftentimes the framework will also dictate the algorithm selection that you use. And then, of course, you want to train your model, you want to validate it, test, and tune it. So, for example, in our email spam detecting example, let's just say that the data engineers have allowed us to get access to 500,000 emails that have been labeled as spam by users. So a pretty decent data set. And we might chop it up 75%, 25%, where 75% of those emails are going to be used for training, and then 25% of those we're going to use to actually validate that our model is accurate. So virtuous cycle until we feel that we've found the best model. Now we're ready to go ahead and take that to production. That's when Kubeflow enters the production phase, and here's where the other personalities that are downstream are going to get involved. Here we're going to transform our data. So now maybe instead of 500,000 emails, now we're working with 100 million emails, right, that have been labeled as spam by users. Maybe we're a big mail provider, an ISP, or something like that. Now, with that same kind of data transformation or processing that we did on our experimental data set, we now have to do on our production data set. So you can see the data volume is much, much bigger, and we're probably going to need a little bit more sophisticated help from our data engineers, our DBAs, maybe our ETL folks, but at the same time, probably more hardware, more processing time, et cetera. So we're going to have to do a much bigger, probably data transformation project. Then we have to retrain that model or train that model that we identified using this much larger data set. And then here's where the rubber really meets the road, is that we now need to serve that model. And typically in Kubeflow, you're going to use something like Kserve, but there are other options we'll get to in just a sec. And then in step four, we basically want to monitor, tune, and retrain the model. So again, it's an iterative process. So in our email spam example, we want to monitor it and we want to tune it because maybe new information is going to come to light, right? Where we may have some new slide technique that spammers are using that we want to integrate into our model, or our data set, we want to add to it every day. So maybe every day, there's 50,000 new emails that have been labeled as spam. How do we incorporate that into the data set, and can the model actually absorb that new information? And at the same time, does our accuracy go up, down? Do we now see false positives, et cetera? Right? You wouldn't want to deploy a spam detection model and assume that it'll still be good 6 months from now. Many things are going to change in that space. Spammers are going to get smarter. You're going to have more data. How do you incorporate that in a production workflow? So that's how we should view a machine learning workflow in kind of a Kubeflow centric way, which is that we have our experimental phase, we have our production phase. We want to make sure that Kubeflow has all the tools that we need to actually make that happen. So the next thing to do is we're going to jump into Kubeflow itself. I'm going to do a quick orientation for folks that are completely brand new to Kubeflow, where all the widgets are, how to navigate it, and then we'll pop into a few of the components and we'll just help orient you where everything is. So if you are able to install Kubeflow, I'd recommend via MiniKF, you'll at least have a roadmap for where all the pieces are and how to get started. Okay, can I toggle between the navigation? Okay, so here's the home. We'll start with notebooks. So with notebooks, the thing to kind of remember here is that Jupyter notebooks are essentially an interactive computing environment that is great for all sorts of things besides data science, right? At the end of the day, it's an environment that supports all kinds of things like rich media, code, markdown, all kinds of stuff, right? But in Kubeflow, notebooks are kind of used in kind of a loose way. So we can mean notebooks as in the document itself. We can mean notebooks as the web app, or notebooks as the server. So it's just something to be aware of as people are throwing around the term Jupyter notebooks, right? So in this view, what we're seeing is these are the notebook servers that I currently have in my installation of Kubeflow. And the way that you set one up is by creating a new server, and you have two options here. One is I can go to a snapshot of an environment and recreate my notebook server from there, or I can use a Docker image that's already been pre-built to do that, right? So that's how you're going to build your notebooks servers. Tensor boards, this is where you're going to manage your tensor boards. Models, these are any models that are being served, and they're going to be served primarily through KFserve or KServe as it's now known. Here's where you're going to see your models that are being served. Again, serving a model is just how do I make it available for other users, services to use. Oftentimes, this is just going to manifest itself as an API. From here, I can manage my snapshots. So what we've done here is that we're using the Rok add-on. So this is something that you're going to get out of the box from MiniKF. Now, with Rok, which is our data management capabilities inside of Kubeflow, I can snapshot whether it be the entire cluster, whether it be a pod, whether it be a notebook. There's different levels of snapshotting that I can do. And in doing so, I can always go back and say, build a notebook server directly from that data from that particular snapshot. So that's capability that you won't find in the stock Kubeflow distro, but it's something that's super valuable, especially if you want to be able to be working, go on vacation for 2 weeks, come back and rebuild that exact environment. Or in the worst case scenario that we described previously, which was someone comes to us and says, we want the exact same environment that existed 6 months ago. Do we have a snapshot that has that can recreate the environment, the data, the metadata, all of the parameterization that we may have done, everything, right? Can we get all those artifacts can we recreate that environment? And when you use something like Rok, you're going to be able to do that. Under volumes, this is where we manage the volumes associated with our cluster. In this case, we're using Rok as our storage class. There's two experiments links here. The first one is going to be experiments as it relates to Kubeflow pipelines. And you can see I've got a variety of them here. But then there's also going to be experiments AutoML, which we'll talk about in just a second. AutoML is really just a way of being able to do data science a lot easier by automating and simplifying many of the tasks that otherwise you would have to hand code or figure out how to get done. So Katib, that's the component inside of Kubeflow that makes that possible. Pipelines, so these are going to be the pipelines that I've set up inside of Kubeflow. Runs are going to be the actual runs of those specific pipelines, right? So you can go into those particular pipelines, look at the graphs for them. And for example, if you want to go into the model evaluation, you can do that. It's fully interactive. You have your visualizations, you have ML metadata. So your metadata is going to be, it can be two things, I guess, it's essentially an ML metadata is going to be a library for recording and retrieving metadata that's going to be associated with this particular workflow. You can also set up reoccurring runs of pipelines. So here what I've done, I've got an hourly run already set up for I should say one that runs every 30 minutes of a particular pipeline. And then the artifacts that are associated with a particular pipeline or a workspace. So the metadata is going to, I think it's going to be divided into two things, right? There's going to be metadata as it relates to experiments, jobs, pipeline runs, and metrics. For those that are curious, this stuff is traditionally going to be held in a MySQL database in a generic Kubeflow deployment. Then you've got artifacts, right? So this is going to be packages and views and any of the large scale metrics. So here we want to think time series metrics, and those pipelines are going to be stored in an artifact store. In this case, we're using Rok as an artifact store for that. So I just wanted to make one last entry point here, which is going to be if we go into notebooks, and you can see I have a notebook already set up here. And again, notebook is kind of used a little bit interchangeably, but here we're actually going into the notebook, and this is by default what you see when you launch. And I've already set up one of the tutorials in here. You navigate to it by going to Kale examples And in this case, the open vaccine, which you'll see a lot of demos are built on, you always want to look for the IPYND file. And you want to recall that these are going to be JSON documents that are going to support not only code, but markdown and graphics and plots and math and all kinds of stuff, right? So it's a format or a tool that's used outside of data science, but has found a relatively good home here inside of Kubeflow, right? So let's just say that within this particular notebook, we're importing necessary packages, we're setting up particular hyperparameters that we want to do, we're showing how to load data and pre-process data, how we're going to define and train the model, how we're going to evaluate it, et cetera. And from here, what you need to do, obviously, once you've done your runs, you may want to actually serve this model. So there's one way to serve the model, right, which is going to models and clicking new model server. And this is kind of what you're presented with, right? Not super intuitive, right? It's going to be a little bit of work, right, to make that happen. But there's obviously a better way to go about it. And that's by leveraging the Kale add-on, right? So Kale is essentially an extension that you put onto your Jupyter notebook. And by simply enabling it, right, and adding a little bit of code at the end here, right, which is, hey, I want to serve this thing using KF server. What I can do then is also tune this job with Katib. So this is going to be my Katib, which is going to be our auto ML capabilities, right? And here it's going to basically load up whatever parameters are available to me, and then I can compile and run that job so that at the end, what I get is this, right? In my experiments view, I can come here, look at the experiment, and I can see that I can quickly identify of all the different runs or experiments that I ran, I can find the one that best satisfied what my objective was here. So I can then go to the trials, right? And here we're looking at 0.666224, which is going to be this one. Then what I'm able to do is just go to the execution graph of it, right? Look at the training from here. And remember, because we are using Rok, I can now go ahead and just grab that URL, right, that for this particular snapshot. And this is what I can then go in, build a new server, right, specifically off that URL, right? So then now I know that I'm going to be able to serve the model that best met my objectives, right? So that's the power of using Kale, which is an add-on, and Rok, which is an add-on to deal with your data management. So then when we come to models, you can see here, I'm serving the best model, right? And you can see here's the storage URI that made that happen. So that's like a super express tour of the Kubeflow UI as it manifests itself when you do use the mini KF package distribution. All the basic functionality is there on top of two very important or kind of super cool add-ons, which are going to be the Kale add-on, right? Which is going to make it super easy to compile and run a Katib job. And at the same time, it's going to give me access to quickly setting up I should say, it makes it super easy to compile and run a pipeline. And at the same time, it makes it easy to set up the AutoML bits or the hyperparameter tuning stuff via Katib. And at the same time, it makes it super easy to serve the actual model with Kserve. So that's why we recommend going with mini KF, as it gives you all that widgetry and functionality straight out of the box. So apologies for getting timed out of the UI. That added a couple of minutes there to doing that, but hopefully visually that was a good kind of preview of what you're going to see in the UI. So with that said, I'm going to go ahead and stop the share.